Mm, yeah, so this is the last thing which we did. That was, yeah. Yeah, we have done this. We were on reactions of alcohol, Michelle, and with combustion. Just to give you an idea, what we are going to do. This is we have done the production of ethanol, and now we are on the reactions of alcohol, right? So we did about the combustion, and this was best fuel. I told you about the products we are going to get for alcohols, that is carbon dioxide and water. And then we did the after that we did the elimination reaction, in which two small atoms or groups are eliminated from two adjacent carbon atoms, resulting in a formation of a double bond, right? And this is called as dehydration as well. So we are done with this reaction, and we also did about the preparation in the laboratory, right? Dehydration of alcohol and preparation of propane. Is it clear, Michelle?
Mm-hmm.
Yeah?
Yep.
All right, good. So now the next reaction we are going to do is oxidation. So have a look here. We are done with this. We are done with the elimination. Now oxidation is left. So we are going to do the oxidation. So oxidation. All right. Now, actually, you know what? Combustion is also oxidation. We have also done combustion, right? Combustion. And what's the difference between combustion and oxidation? The very first difference is in combustion, we use O2, and in oxidation, we use atomic oxygen, right? The second difference is we do not need no need of oxidizing agent, no need of oxidizing agent, and oxidation doesn't take place without the oxidizing agent. So oxidizing agent is a must. Now there are two main oxidizing agents which we use for the oxidation of alcohol. Number one is acidified KMNO4, and the other one is acidified potassium dichromate. So if we talk about their color, let me write this with another color so it will be clear to you. So acidified potassium dichromate is of orange color. Potassium dichromate K2CR2O7. So after oxidation, it changes to green color. However, potassium permanganate, I'm going to write it with black color or dark brown color because it turns colorless. So there, I
Mm.
can't mention it with the color. So I will simply write that acidified KMNO4, it turns colorless, right? I'm going to just shift it to somewhat here. All right. So it is colorless. I think it's clear. Yeah. So it turns colorless. So this is the main difference between combustion and oxidation. However, combustion, we need ample supply of oxygen in it, right? So now we are going to do the oxidation. Actually, when we talk about the alcohols oxidizes according to the uh, type of alcohol. Type of alcohol. That means if we are going to take primary alcohol, if we are going to take primary alcohol, it will react differently. That is 1 degree alcohol. If we take second degree alcohol, which is called as secondary alcohol, it will behave differently. And if we have tertiary alcohol, it will behave differently. Tertiary alcohol. Now, as far as primary alcohol is concerned, first it changes to ethanol on oxidation, and finally it is further, ethanol. Ethanol, and then on further oxidation, it turns to ethanoic acid, which is a carboxylic acid. So, what is ethanol? It's an aldehyde. And what is ethanoic acid? It's carboxylic acid. As far as secondary alcohol is concerned, when we do the oxidation of secondary alcohol, it changes into ketones, and ketones is not further oxidized. As far as tertiary alcohol is concerned, tertiary alcohols cannot be oxidized. So there is a direct cross in front of tertiary alcohol. Does it make sense, Michelle?
Yeah.
All right, good.
Mm.
Now, first of all, I'll give you the example of primary alcohol. So, ethanol is a simple example of primary alcohol. All right. Now, as far as propanol, it's the example of secondary alcohol. All right. And as far as tertiary alcohol is concerned, tertiary alcohol is not further oxidized. First, we will do these two. And after that, I am going to tell you about the tertiary alcohol. Tertiary alcohol is something in which OH group is linked to the carbon atom, which is further linked to three other carbon atoms, right? So this is called as tertiary alcohol. Always keep this thing in mind. You need to memorize it, that primary alcohol will oxidize to, you need to memorize it. It's better. The sooner you are going to memorize about this, the better it would be for you. So that primary alcohol is oxidized to ethanol, which is an aldehyde, and it is further, if you are not going to distill the product, it will eventually change to ethanoic acid. That means if you want to distill ethanol, you have to stop the reaction and then distill ethanol. If you will not stop the reaction, it will go to completion and it is going to produce ethanoic acid. Secondary alcohol, after oxidation, it produces ketones, which are not further oxidized. Tertiary alcohol will not at all oxidize. I have already given you the example of the first primary alcohol, that is ethanol. Secondary alcohol, propanol. And if you want an example for the tertiary alcohol, this would be 2-methyl, 2-methyl propanol. Now I am going to make it so that you will get the idea. This is tertiary alcohol. Ethanol, let me make the product. Ethanol, that is 1, 2. This is S means 2 carbon atoms. So have a look here. This is ethanol. Now, this is ethanol, right? So CH3, that here, CH3, CH2OH. So CH3, CH2OH is an example of primary alcohol. Now comes the secondary alcohol. The example I give you is propan-2-ol. So propan means 3 carbon. So 1, 2, and 3. 2-ol means, first of all, I have to number it. You can start the numbering from any side. The middle carbon atom is going to get the number 2. So 1, 2, 3. So it's propan 2-ol. 2-ol means that the functional group would be on the second carbon atom. So I'm going to put OH here, and then I'm going to satisfy the rest of the valencies with hydrogen atom. So this becomes like this: CH3CH in bracket OH, then CH3. How come? CH3, CH3, CH in bracket OH, and then CH3. This is secondary alcohol. Is it all clear, Michelle, what I'm discussing?
Mhm.
Yeah,
Yep.
good. And then tertiary alcohol. Let's make tertiary alcohol 2-methyl propan-2-ol. So the very first thing is 2-methyl propan-2-ol is this thing. This is propan-2-ol. So you can copy the same thing, paste here. So this is actually what this is. Here it is. This is propan-2-ol. Now you simply need to add a methyl group. Oh dear. You simply need to add a methyl group on second carbon atom. So what would be the change in it, beta? You are going to do like this. That is um, CH3 like this. So this would become, now this is 2-methyl propan-2-ol. So have a look here. If you want to write it in another way, there is one more way to write it. That is, um, uh, write it as a cumulative form, CH3, COH, CH3, and this one as accumulative form, CH3. So this is another way of representing the um, tertiary alcohol, or it can also be, this is one way of representing it, this is the second way of representing it, and this is the third way, that is CH3, CH3OH, CH3. So this is the third representation. Now you know that it will be oxidized, this will be oxidized, but this will not be oxidized. Now let's check that, how to make the alcohol being oxidized in the presence of oxidizing agent. All right. So please, I'm repeating it again and again. Let me highlight this. This is very important. You need to learn it by heart. The sooner you do it, the better you are going to get the grip of the topic, right? So I'm not going, I'll do it only once. So this and this. So now let's start it. The first one I'm going to take is primary alcohol. Now have a look. I am writing ethanol. That is, I will write it like this so that you will get the idea how to do that. So H, and H. Oxidation, if you remember, the one definition of oxidation is the number one, removal of hydrogen and, I'll write here. Number one, removal of hydrogen. That is also called as oxidation. And addition of oxygen. That is also called as oxidation. Addition of oxygen. Let me tell you, it's better. There are actually four definitions of oxidation. So if you are going to comprehend, or if you are going to memorize all of them, it will help you a lot. Let me write it down. That is oxidation and reduction. So I'm telling you the four definitions of oxidation and four definitions of reduction. Number one, loss of electrons. Number two, increase in oxidation number. Oxidation number. Number three, loss of hydrogen. And number four, addition of oxygen. All right. Now, the opposite, as you know, that the opposite of oxidation is reduction. So I'm going to write down the definitions for reduction. Now, opposite to this, whatever is written here, let me highlight it. Loss of electron, increase in oxidation number, loss of hydrogen, addition of oxygen. Now, just do the opposite of it. If oxidation is loss of electron, then reduction would be what, Michelle?
Gain of
Well
electron.
done. Gain of electron. Shabash. Number two would be reduction. If oxidation is increase in oxidation number, then reduction would be,
Decrease.
yes, well done. Decrease in oxidation number. In
Isn't
oxidation.
this called like oil recursion?
Oil rig. Oil rig gives only one type of definition, bitter. Oil rig oxidation is loss.
Okay.
Reduction is gain. So it only gives this definition. Look, oxidation is loss of oxidation. Oxidation is loss of electrons. Reduction is gain of electron, right? So it gives only one definition. I am telling you four definitions because they are going to help you a lot. Sometimes students, they don't know that all of these are the definitions of oxidation. They only stick to this, and when they come across these things, they cannot figure it out that this is also called as oxidation. So that's why I'm telling you all the definitions of oxidation and all the definitions of reduction. Now the third, is it clear, Michelle?
Yeah.
Now, the third definition, as I told you, that if loss of hydrogen is oxidation, then what would be reduction?
It will be gain of.
Well done. Gain of hydrogen would be reduction. And the last one, addition of oxygen is called as oxidation. So, what would be reduction then?
um like taking out.
Yes, removal of
Oh,
oxygen.
yes. Okay.
Yeah, removal of oxygen. Now, these are the definitions. Now, if you want me to apply these definitions, I'll apply them. Loss of electron and increase in oxidation state, they go hand in hand, right? For example, zinc, which is a reactive metal, when it loses electron, it forms zinc plus 2e. Now, as I told you earlier, that if you write the electrons before the arrow, it is called as addition of electron. If you are going to write the electrons after the arrow, this is called as loss of electrons. So if you can see that I am writing the electrons after the arrow. So this is the loss of electrons. So this is oxidation. And if you check the oxidation, now the first definition is done. Yes, Michelle? Loss
Yeah.
of electrons. So this is the loss of electron. Electrons are, these electrons are lost, right?
Mhm.
Lost. Now, as I told you, that they make a pair. Loss of electron and increase in oxidation number. Whenever a metal is going to lose an electron, there will be an increase in oxidation number, right? So that would be increase in oxidation number. How come? Bete, all the atoms or elements which are present in the periodic table, their oxidation number is zero. So from zero, it is changing to plus two. So 0 plus 1 plus 2. So that is called as increase in oxidation number. So the second definition is also fulfilled in the same equation. That is why I told you that it acts in pairs. So whenever an electron is lost from a metal, definitely there will be an increase in the oxidation number, and which is also called as oxidation. Does it make sense, Michelle?
Yeah.
Good. Now, the third one, loss of hydrogen and addition of oxygen. You will see these two definitions in action when I'm going to oxidize primary alcohol. Now, let's start it. All right. Is it clear, Betty? Now, I'm
Mm-hmm.
going to do the primary alcohol, that is ethanol, which is a primary alcohol. I'm going to do the oxidation of primary alcohol. And in this oxidation, I am going to use the third and the fourth definition. All right. So have a look here, beta. This is ethanol, CH3, CH2, and OH, CH3, CH2OH. This is primary alcohol. Now let's do the oxidation. That would be oxygen, O, like this. So what is going to happen? Be very careful when I'm going to tell you this thing. The third definition is loss of hydrogen. Now see, this hydrogen beta, this hydrogen, and this hydrogen would be lost. So this would be complete. Now, when these two would be lost, what I am going to get? CH3 would be copied. So I'm going to copy CH3. Have a look. CH3 will be copied. And then CO, this is lost. This is lost. So I am left with C double bond OH, right? And now these two, so look, the third definition has been fulfilled. Loss of hydrogen. So one and two hydrogens are lost. And look, when you lose it, you will be left with COH. So have a look, C double bond OH. Now, because I need to satisfy the valency of carbon, which is 4, so 1, 2, 3, 4. So that is why otherwise here it is 1, 2, 3, because the fourth bond of the fourth bond is made with this hydrogen. Now, this hydrogen has been lost. So in order to satisfy the valency, I have to put the double bond here. Now, loss of hydrogen is done. Now, the fourth definition of oxidation is addition of oxygen. Now, as I told you that these two hydrogens would be lost. Definitely. Now, these two hydrogens, they are going to combine with this oxygen to make water. So, I am going, so now plus H2O. Now, the first definition is fulfilled, that is loss of electron. Now see how the second definition will be fulfilled, addition of oxygen. Now have a look. I'm going to write water a little bit to this side so that you will get the idea. As I told you that if you are not going to distill, this is aldehyde, if you are not going to distill off this product, the reaction would prolong, or it would go to completion. And now what is going to happen, oxygen will be added, and this oxygen, I'm going to show it with the red color so you can see, this oxygen will go here. Now what I am going to get, let me write again, CH3, C double bond OH, and this oxygen will be added here. So now look, addition of oxygen. Now the last definition, addition of oxygen. So you can see first of all, the hydrogen was removed in the first conversion, and then oxygen is added with this H. And now what is it, beta? This is carboxylic acid. This is carboxylic acid. And what is this? This is aldehyde. All right. Now have a look, Betty. I have already told you that primary alcohol changes into ethanol, which is aldehyde, and then ethanoic acid, which is carboxylic acid. So have a look. Ethanol, which is primary alcohol, changes to ethanol, which is aldehyde, and finally it changes to ethanoic acid. So you can write it like this. This is always keep this thing in mind. This is ethanol. Ethanol. There is another way to represent it, that is CH3, C double bond OH. So this is ethanol. This is ethanol, and this is ethanoic acid. So you can also write it CH3, where here CH3, C double bond OOH. So I will write C double bond OOH. So this is ethanol, and this is ethanoic acid. Now, do you want to, yes, is it clear? Do you want to ask any question, Michelle?
I understand this so far.
Well done. Now, the second one, that is secondary alcohol. Which example have I given you for secondary alcohol, Michelle?
Ketone.
Which example? I'm asking about the example of secondary alcohol. What is the example? Can you name any compound which is secondary alcohol?
Oh, like my own. Shall I just think of one?
No, 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 no. I have told you, Michelle.
Um,
It's right there on the screen, Michelle.
a secondary alcohol examples. These ethanol.
But this is secondary alcohol. It is written here in front of you. So, what is secondary alcohol?
Oh, propan one two or
Propanol. This is the example of secondary alcohol. Michelle, beta, be very attentive, beta. All right, now secondary alcohol, propanol. Now tell me, a secondary alcohol, propanol. Number two, secondary alcohol. So have a look. The example is propanol. So let's do it. Now let's make secondary alcohol. Okay, so CHCC and propan 2 also C, and OH would be here, and the rest would be satisfied by hydrogens. So this is secondary alcohol, right? So better now be very careful when you are going to, the same thing is going to happen, that you will remove the first definition is here, loss of hydrogen. So hydrogen would be lost. from where? Now be very careful. Let me highlight this hydrogen and this hydrogen would be lost. And in the primary alcohol, these two hydrogens were lost. In secondary alcohol, these two hydrogens were lost, right? And now again, I am going to do the same thing, beta plus O. Now, these two hydrogens will combine with this oxygen to make water. So, what is left? CH3, C double bond O, CH3. This is left. So, I'm going to write beta. Now, let me highlight it so you will get the idea. CH3, C double bond O, CH3. This will be left. So, let me write that is CH3. C double bond O, CH3. This can also be written like this. And what is this? This is the first representation. This is the second representation. And what is called in both the cases, what do we call it? Propanone. Propanone, which is actually a ketone. So secondary alcohol, I told you beta, here it is. Secondary alcohols are oxidized to ketones, and ketones cannot be further oxidized. So here it is. Secondary alcohol is oxidized to ketone, and ketone cannot be further oxidized, plus H2O. You cannot oxidize ketone further. Why? Because oxygen can never be added in an alkyl group. So this was the only place where oxygen could be added, and we have already added it, right? So this is ketone, which is not further oxidized. Does it make sense, Michelle?
Yeah.
All right. Now the last one, and what is it? Yeah, this is propan to all. And what is this? Propanone. All right. Tertiary alcohol. Tertiary alcohol. I have already given you the example bit of tertiary alcohol. Here it is. This is tertiary alcohol. This is tertiary alcohol. 2-methyl propantool. 2-methyl propantool is an example of tertiary alcohol. Let me write it and then I'll tell you why you cannot oxidize it. So tertiary alcohol would be what? CH3, COH, CH3, and CH3. So this is tertiary alcohol. What is this? 2-methyl propan to all. Now, if you will try to oxidize it, plus O, I am going to write a big cross. Why? Because it is surrounded by three methyl groups, and methyl groups can never be oxidized. And this only hydrogen was left, and this hydrogen also already has a has an oxygen atom. So further oxygen cannot be added here. And in block letters, I am going to write alkyl groups cannot be oxidized. So that's about this is the end. That's about it. This is the end of the this is end of the oxidation of alcohol. Is it clear? Anything you want to ask, Vita?
No.
Sure.
Yes.
Good, well done. So now the experimental details in your syllabus, the experimental details are also given. So we are going to look at them. Experimental details. All right. So when we will do the oxidation of alcohol, we need to have Liebig condenser and distillation apparatus. So what is it? Let me show you how we are going to do it. So first of all, we are going to have uh, uh, this one like this. and this, and then we are going to attach this, and there is a water inlet and outlet here, and then it goes into the distillation flask. So now what are we going to do? We are going to have here mixture containing, here it is, mixture containing water, ethanoic acid, and residues. And this is the Liebig condenser. We are going to have a Liebig condenser here. This is water out, water in. This is the distillation apparatus basically. And then we are going to put a thermometer here. The bulb of the thermometer should be right in front of the Liebig condenser. So this is thermometer. Now what is this? This is called as the distillate. This is the distillate. All right. So what we are going to do, as I told you earlier, that uh, for the oxidation of alcohol to aldehydes and ketones, we must have an oxidizing agent. And I told you that the oxidizing agent is actually the acidified KMNO4 or acidified K2Cr2O7. I told you about the colors. Can you tell me the colors for KMNO4 and acidified potassium dichromate, Michelle?
Yes, so you said that it'll go colorless.
From acidified KMNO4, colorless from what color?
Um, like,
Purple,
isn't it blue?
purple,
Oh,
purple to colorless. And what about potassium dichromate, Michelle?
um, the color or
Yes,
the
but
after.
the color.
It'll be isn't it like orange or like red orange?
Orange, orange to what?
Um, is it it
Bitter
was
green, green,
green.
orange to green. All right, fine. Ethanol vaporizes as it forms and distills off. Now, it's entirely up to us, right? So that do we want the reaction to be stopped at ethanol, or do you want the reaction to go to completion? All right. So here we have an alcohol. Let me write an alcohol, not an acid. Alcohol, alcohol, right? And then we are going to add what? We are going to add the ethanol. Here we can, there are two ways we can do it. We can have the ethanoic acid water to get the pure ethanoic acid here. Ethanoic acid plus water. All right, so this is the way to prepare the ethanoic acid. However, if we take an other apparatus in which, if we have this apparatus like this, and then this is water in and water out, and then we have a flask in which we have the first degree alcohol plus excess K2Cr2O7 plus concentrated acid and plus heat. So we should have uh, uh, This is the Bunsen burner, and we then heat it. And what is going to happen? This alcohol would turn into ethanoic acid. So this is another way of making ethanoic acid. I hope it's clear. So ethanol, right, ethanol changes to ethanol, which changes to ethanoic acid. Is it clear, Michelle?
Yeah.
Any confusion, Betty? Any question?
No, I understand.
Well done, well done. All right, so um, keep this thing in your mind that when we are going to get the um uh, ethanol, what is going to happen? The temperature of ethanol is actually 21 degrees centigrade. It vaporizes at 21 degrees centigrade, but you need to distill it off as soon as it is formed. So this is the distillation apparatus. This is water in and this is water out. So eventually it changes into ethanol. This thing changes into ethanol. And then if you are not going to distill it, it will change eventually to ethanoic acid. All right. So in a breathalyzer test, for example, the drivers should not have the ethanol greater than the amount which has been prescribed. So the breathalyzer test is used to check the ethanol level in the blood stream blood in the blood. The ethanol concentration is checked through the breathalyzer test. The concentration of ethanol should not be more than 80 milligram in 100 centimeter cube of blood. So if the concentration of ethanol is more than 80 milligram in 100 centimeter cube of blood, that means that it is illegal. So for this, a quick breathalyzer test is used, right? So the person is asked to blow out in a tube which contains potassium dichromate. So definitely, if the person has taken a lot of ethanol or more than the prescribed value, what happens that the color of the oxidizing agent, that is potassium dichromate, it rapidly changes from orange to green if the amount of alcohol is more than the expected value. So in this way, they can quickly check that whether a person has taken a lot of alcohol or not. Is it clear?
Yeah.
All right. So we have already done the oxidation. We are done with the full topic of oxidation. Now I'm going to start the test for aldehydes and ketones. This is again a very important topic. That is tests
Are these
for.
all practicals?
This is not practical, this is practical, but actually you need to know about this. In the paper, you can be asked about this. This is not practical. All right. You can do the practical in the lab, but in the theory paper, you will be asked about these, right? This. Okay.
Yeah.
Maybe your teacher has done the practical with you. Breathalyzer test is definitely something which is practical. Breathalyzer test. Have you done anything related to alcohol in the lab?
No, not yet.
Or maybe your teacher will show you an experiment where you can change the primary alcohol into ethanol or ethanoic acid, right?
Mm-hmm.
So now what I am going to tell you, that is 100% practical. This thing, test for aldehyde and ketone. Maybe when your teacher will take you to the lab, she's going to show you these tests. The first test is a very famous test, that is silver mirror test, right? So test for aldehydes and ketones. Aldehyde and ketones, they have similar properties, but physical properties, but there are two tests that can tell them apart, right? So both of these tests involve gentle oxidation. So if you want to differentiate between aldehyde and ketone, there are two tests. The first test is called as Tolin's reagent. Tolin's reagent. Now, first of all, let me tell you what is Tolin's reagent. That is called as ammonical silver nitrate. That is called as Tolin's reagent, right? So a silver nitrate is AgNO3, aqueous. So ammonia is mixed with silver nitrate, right? And this is called as silver mirror test. Tolin's reagent gives silver mirror test, and this is only given by aldehyde. Silver mirror aldehyde. Silver mirror test is not given by ketones. So this test, I will write, this test is not given by ketone. So this can easily differentiate between aldehyde and ketone. So if you are going to add aldehyde, then you are going to get a silver mirror, and if you are going to add ketone, you will not get a silver mirror. Now I will tell you how you can do that. Is it clear, beta?
Mm,
I'm going to tell you about it. I
okay,
haven't
okay.
started it, right? So, when we will be done with this test, then if it is not clearly understood, you can tell me. I will explain it
Okay.
again, right? So, what is silver mirror test? Actually, Tolin's reagent, what is Tolin's reagent? Ammonical silver nitrate. This is a mild oxidizing agent. Oxy, oxidizing agent. Mild oxidizing agent. So it is a solution of silver nitrate in aqueous ammonia. I have already told you about that. Ammonical silver nitrate. So it oxidizes aldehyde but has no effect on ketone. It contains colorless silver 1 complex ion containing silver which are reduced to metallic silver as the aldehyde is oxidized. Now you know what you need to do. Take a test tube. Take, let's suppose a colorless solution is given to us. A colorless solution is given to us. We do not know whether it's an aldehyde or ketone. We do not know. So we are checking. So we are going to add this colorless solution in the test tube. Colorless solution in the test tube. This is the colorless solution. Then we are going to add Tolin's reagent. All right. So we are going to add Tolin's reagent. So what is this? This is Tolin's reagent. And what is Tolin's reagent? Ammonical silver nitrate. Ammonical silver nitrate. Now, when I am going to, I will add it, and then I will put the test tube in water bath. This test tube I will put in the water bath. Now, this test tube, I will put it in the water bath at 80 degrees centigrade, right? Now, what does this test tube contains? This test tube contain a colorless solution. We want to know whether it's aldehyde or ketone, and plus Tolin's reagent. Now, Michelle, now let me add the color, black color. Now, if the sides of the test tubes, they get shiny silvery black, so black that it turns into a mirror, and you can easily see the reflection in it. That is called as, if a silver mirror is formed, that means the thing was 100% aldehyde. So it is aldehyde, not a ketone. All right. And why the silver mirror is formed? Because as I told you that we added Tolin's reagent, which is actually Ag1 nitrate. All right. So what happens? It contains colorless silver ion, which are reduced to metallic silver. Metallic silver. And metallic silver is black in color. It is black in color. Okay. So what is going to happen if this colorless solution is aldehyde, then we are going to get the, sorry, if the colorless solution is aldehyde, then we are going to get silver mirror. If it is ketone, then no silver mirror is formed. Now tell me, is it clear? Or if something is not clear, I will explain it again. Now tell me.
No, understand.
All right. And always keep this thing in mind that you need to put the test tube in water bath at 60 degrees, 80 degrees centigrade. Then you are going to get the silver mirror. All right. Now, as I told you, to differentiate between aldehyde and ketones, we have two things or two tests. The first test is the Tolin's reagent test. I'm going to highlight this Tolin's reagent. The second test would be what? It would be Falling's test. The Falling tests. The Falling test, right? And what is a Falling solution? Actually, it is a blue color solution. Blue color solution of copper hydroxide, right? Blue color solution of what? Copper hydroxide. All right. Is it clear? And this copper hydroxide is having copper plus 2. After the oxidation, it changes to copper plus 1, which is of brick red color. I am repeating it again. Copper 2 is blue. After oxidation, a positive 2 changes to positive 1. The color of copper positive 2 is blue, and the color of copper positive 1 is brick red. So it changes the color, right, Michelle?
Yeah.
All right. So again, what you are going to do, better, you will take a test tube. And now I'll show it here. You will take a test tube. You add a colorless solution into it. Colorless solution. You just want to confirm whether it's aldehyde or it's ketone. You want to confirm that. So what you are going to do, aldehyde. So what you are going to do, you are going to add dark blue copper hydroxide in it. Copper in the colorless solution, you will add copper hydroxide, which is of blue color. If it changes, and then you if it changes to red precipitate, that means aldehyde is confirmed. If nothing happens, then it means it is ketone. All right. So what happens during oxidation, copper positive 2 beta, copper positive 2. Here it is. So copper positive 2 will take up an electron because it is called as reduction, and it changes into copper positive 1, which is of brick red color. All right. So that's it. So it changes into copper 1 oxide. This is copper 2 oxide, and this is copper 2 hydroxide rather, and this is copper 1 oxide. All right. And on warming, you have to warm it as well. You have to, oh dear, you have to vomit. So if it changes color, if the color change takes place, if the color change takes place, then it is aldehyde. If no color change takes place, then it's ketone. Takes place, then it's ketone. So what are the two things? Can you repeat it, Michelle?
Um, so if the color doesn't change place, then it'll be a ketone.
Yes. And what are the two things? So how to differentiate between an aldehyde and ketone? What are the two reagents? Differentiate between aldehyde and ketone. Yes, Pete. What are the two reagents?
Um,
Yes.
the two
Tolin's reagent.
Torrance reagent
And the second
and
one is Falling's solution.
Fellings.
All right.
Yes.
Yes. So
Will you say
Falling's
reagent or test?
Tolin's test or reagent is one and the same thing. You can write test. If it is bothering you, you can write test. No problem.
Okay. What does reagent mean though?
Reagent is also something which you add.
Okay.
So when you are going to add bitte, when you are going to look, silver nitrate, this is a reagent. All right. So anything which you add is called as reagent. All right. So what is Tolin's reagent? Can you tell me what is Tolin's reagent? It is what?
Um, like what it is.
Yes, what it is.
Um, so it's like it reacts with Torrance to form like
What?
the silver.
Yes, but what
Oh,
is Tolin's reagent? But I told you it's ammonical silver nitrate.
okay.
It's ammonical silver nitrate aqueous. Ammonical means ammonia and silver nitrate. All right. And I'll keep this thing in mind that silver nitrate is colorless. And if it changes to black silver mirror, then aldehyde is present.
Okay.
If not, if no silver mirror is formed, then it is ketone. All right. The other thing is beta Falling solution, which is copper hydroxide. It's copper positive 2. It's of blue color. All right. Then you add the aldehyde slash ketone, any one of it. Now, if it changes to red precipitate, then aldehyde is confirmed. If no color change, then it is ketone. Is it clear?
Yeah.
Michelle, is it clear? So we
Yeah.
are done. We are done with the whole chapter. We have finished this chapter as well. All right. And you were talking about the practical chemistry. The practical chemistry is in the next chapter. All right.
Yeah.
So, yeah, can we do some questions, Michelle?
Okay.
All right. State now, you will give me the answer. All right. So, state what happens when the following alcohols are oxidized as much as possible by acidified potassium dichromate. So, if you are going to oxidize primary alcohol, what you are going to get?
Um, I'll the primary alcohol will give you aldehyde.
Well done. So, shabash, it is going to give you an aldehyde. All right. And if
Mm.
then what else? If you will not distill aldehyde, then what would happen? First, it will change to aldehyde, then.
Wait, what's your question? Can you repeat the question?
Yeah, I can repeat the question. I'm saying if you are going to oxidize primary alcohol, first it will change to aldehyde. And then, if you are not going to distill aldehyde, if you will keep on heating it, then what you are going to get?
Um,
I told you, Michelle.
the carboxylic
Yes,
acid.
yes, well done. Carboxylic acid. Shabash. Carboxylic acid. Now, if you have secondary alcohol, then what is going to happen? It will oxidize to what?
Um, Ketone.
Ketone. Shabash. Ketone. Well done. Now, the next question is why tertiary alcohol cannot be oxidized?
Um, it's
Why
because
tertiary? Yeah.
it's because they don't have the hydrogen atom.
Cannot be oxidized. Bete, tertiary alcohol. Okay, fine. This is tertiary alcohol. This has a hydrogen atom, but it is already oxidized, right? So there is no, and the rest are the methyl groups, which cannot be oxidized. Is it clear?
Yeah.
Number one, there is no separate hydrogen atom, right? There is no separate hydrogen atom. There is only one hydrogen atom which is already having an oxygen. The rest are the alkyl groups which cannot be further oxidized, right? Now,
Mhm.
what is the difference between distilling and refluxing?
Um,
Hmm?
Distilling and refluxing.
Yes, distilling and refluxing. Distillation and refluxing. Better refluxing is slow, continuous heating.
Oh yeah,
Slow,
yeah.
continuous heating, right? And distillation is when you are going to put a condenser. All right. In distillation, you put a condenser. You know what? Betty, when you are going to, let's suppose, as I told you, that you need to take the oxidizing agent in the conical flask, right? And you heat the mixture gradually and gently in apparatus. And then what would happen? The receiver is cooled in ice to reduce the evaporation of the product, and ethanol vaporizes as soon as it is formed and distill off. This stops it from being further oxidized to ethanoic acid. All right, and unreacted ethanol remains in the flask. Is it clear?
Yeah.
All right. So that means this is called as a slow, gradual heating. If you are going to give the continuous heating, you are going to get ethanoic acid from primary alcohol. Primary alcohol will change to ethanol, but because you are continuously heating it, so you are going to get ethanoic acid. But when you do the distillation, then if you are taking primary alcohol, you are going to get only ethanol. That's it, because this is the difference, right? But if you are going to do slow continuous heating and refluxing, then you are not going to get ethanol, you will get ethanoic acid. Is it clear?
Yeah.
All right, well done. Now the next question would be, um, uh, uh, write the equation for the elimination of water from ethanol and name the product. Yes, tell me.
Um,
Elimination of water, ethanol. Now, first of all, make me write the ethanol. How can I write ethanol?
Um, like the formula.
Yes, yes, the formula. Write the equation. Write the equation for the elimination of water from ethanol and name the product. Yes, Peter?
So ethanol will be Ca2H4O.
No, Peter, no, I didn't tell you like this. I
Oh,
didn't tell you like this.
or like the
I,
other way,
yes,
CH2 and then
I,
double bond like that.
yeah, I didn't tell you C2H4O. Ethanol. No, there is no double bond in ethanol, Misha. There is no double bond, Beta. Can you tell me the
Oh,
formula of ethanol?
CH2, then CH, then OH.
CH2, then CH, then OH. It's all wrong.
Oh,
This doesn't exist, Beta. Ethanol has a formula. Ethanol has a formula CH3, CH2, OH. All right. Okay.
mm,
So you will write it like this, like this. All right.
yeah.
CH3, CH3, CH2, OH. Now what you will do, beta? What's the next step?
Um, what do you mean, like next step for the
Beta, I
um?
have written the question. Now. Write the equation for the elimination of water from ethanol and name the product. That is, you know that ethanol is primary alcohol. So when you
Oh,
are going, yes,
so will you do an arrow
okay.
and then you'll put ethene, like you'll make ethene, right?
Okay, so you get it well done. So what you can ask me, you should have told me to write OH here, right? And now, Betty, you can remove this, okay? Well done. So you are going to get, when this will be taken out, you will be left with this and this, right? So well
Yeah.
done. So I'm going to get CH, CH, double bond, CH and CH. Or it can be written as CH2 double bond, CH2 plus water. All right, so what's the name? This is alkene or ethene. Well done, Michelle. Ethene or alkene. And the second product is water. All
Yes.
right,
Hmm?
okay. I hope it's clear.
Yes.
All right. Now, only I am giving you, we have done, let me tell you, on page 239 of your book, we have summary questions. Summary questions. We did from question number 1 to question number 5 in the class. In the class, I am giving you only you need to rewrite them and then do question number 6 and send me the homework on WhatsApp group, right? All the questions you need to do. We have already discussed question number 1 to 5 in the class, but you need to write them again, and you will do question number 6 and send the homework over the WhatsApp group. Is it clear?
Yeah.
All right. Okay. Thank you so very much, Michelle. I started the class at 5:26 and I'm ending it at 6:30, right? So I have um, um, uh, given you the proper time, which was 1 hour. Is it clear? Any
Yeah.
question, Betty?
No, I think I understood today.
Well done. And don't forget to do the homework and submit it on WhatsApp group, right?
Okay, that's fine. Thank
Okay,
you.
thank you.
Wait, can
Welcome.
you send the homework on the group as well?
Yes, yes, I'm going to send it.
Thank
Okay.
you.
Take care. Bye bye.
Bye.